Hello and welcome to my channel. I am Mayank and today we'll be talking about DevOps and the related concepts around DevOps and what exactly is the buzz around DevOps. DevOps as a tool is gaining a lot of popularity in the IT world, and I believe everyone who is directly or indirectly a part of the IT industry should know at least the fundamentals of DevOps. So without saying further ado, let's get started. Most of us at least once would have come across something like this, which we call a DevOps Infinity, and a lot of people, developers, all coming from different backgrounds, would not have much idea about what this means. So that is what we're going to try to explain going forward. Before talking about DevOps, let us first understand how application development happens in an ideal scenario. I have a small example here where we start with a problem statement and then we go to the language selection wherein we decide what programming language we'd be using to solve that particular problem statement. The next step is definitely to write the code and implement the same using the language of our choice. Once done with the code, we try to test compile the code so that there are no errors in the code, and if everything is green, we just try to run the code and it's celebration time. This is generally how applications are developed. I have a small example here. Say suppose you've got a problem to add two numbers and your choice of selection is Java. Then you go and write a file called sum.java with addition logic inside it, and then you try to compile it using a command called javac. Javac is a compiler for Java, and we pass the file that we created in the previous step sum.java to check there are no syntactical errors in the code. Once the code compiles properly, we can run the code using a similar command called java sum, and it'll give us the results. So that is our celebration time. The whole point here is to understand how application development takes place. We get a problem statement, we choose a language, we implement the code, we try to compile the code in a test or a local environment, and then we try to run the code. The next topic, which would be of our interest to understand DevOps, is the distinction between local and remote environments. So, what is the distinction between local and remote environments? Say, suppose you're a developer and you're working on solving a problem statement in Java. You go reach out to your laptop and try to code it out. So, here your laptop is your machine, which is a local environment. In contrast, when we try to develop applications for enterprise, we do it on something called as a bare metal server or a serverless model, which can be hosted on a cloud provider such as AWS, Azure, or GCP. These together are called remote servers. Now, bare metal servers are actually physical servers that you buy and install as a rack server, and serverless are the solutions that you get out of the box from the cloud providers. Now, to make things more clear, I would give certain words which would establish the distinction between local and remote servers. Say you're prepping up for a test and then you go for a mock test, which happens generally from your home location, or generally you go up to an institute and do a mock test. But then the actual test, which happens, is the remote environment. Another example would be when you're practicing for some performance, you do the rehearsals in your as your comfort. You do the rehearsals in some facility and then you actually do a stage performance. So that is the real distinction between local and remote environments, wherein local environments would be something which is your machine where you have access to deploy and read the files, whereas remote servers or remote environments would be the server options that are hosted outside of your development environment, that are meant only to deploy or run your applications. That being said, let us move to DevOps and what is the buzz around DevOps. A little while ago, we saw this flowchart which tries to indicate what are the steps involved in creating or developing an application. So, now definitely in an enterprise setup, you would not be required to do everything by yourself. So, there's a shared responsibility model that comes into picture. So, the first block that you see here, language selection, implementation of the code, and compiling of the code in your local environments, is something that falls into the hands of the developers. Whereas the yellow box that you see, testing the code on a remote server or running the code on the remote server, is something that comes into the bucket for an operations guy. So the blue box here has all the responsibilities for the developer, whereas the yellow box here can be said are being looked on by the operations team. Now, DevOps takes care of all these things. By that, I do not mean that DevOps people write code and try to implement solutions for their problem statement. If that was true, then most of the developers would be outside of their jobs by now, but that is not true. So, in a nutshell, we can say that DevOps kind of overlooks across everything that involves an application development and delivery. But that is a very broad term to say. So, what exactly do DevOps engineers do? Well, DevOps engineers have only one responsibility, which is to provide a stable and a consistent environments where applications can run smoothly and everybody is happy. This also means that DevOps engineers create environment infrastructure, be it bare metal or cloud native. So these are remote servers that we earlier discussed in the previous slides. DevOps engineers are also responsible for creating automations to build and test your code on the fly. They are also responsible equally to deploy these applications which are built in the previous step to designated servers, be it bare metal or cloud native infrastructure. DevOps engineers also have a role in creating health monitoring mechanisms so that applications are performing well at all times. And they also have a responsibility towards setting a real time application logging mechanism so that any abnormality can be traced back in the logs. In addition, they also have to set up a high availability, which means your applications deployed onto the cluster in an enterprise setup should be available most of the times. In addition to that, DevOps engineers are also responsible for setting backup and recovery solutions for the applications deployed onto the environments. And if that was not all, DevOps people also have to keep the developers happy all through this while. So that's a pretty big task to do. I would definitely agree that is a task to do. All right, so the next thing that we can talk about is the DevOps Infinity, and this was a slide that you saw earlier, and people get confused looking at this Infinity as what it is. And so these are various phases of the application development and delivery. We start with the plan phase, where we plan what is the problem statement and how that problem statement can be broken down in smaller modules that can be handed over to developers to write code and implement solutions. The next step is to create the solutions, which is again in the developers bucket. Developers need to verify and package the applications and send it for deployment. Here, DevOps engineers are also required to test, verify, and package applications on their end so that everything seems good. Going forward, DevOps teams needs to deploy those applications in form of a release and then finally configure the servers or adjust or fine tune the servers accordingly wherever required, and then a continuous monitor is set up on the application that is deployed. At the end of the Infinity, we again start with the plan phase for the next module or the next iteration, and then the loop continues. So this is basically the model how things flow in a DevOps world. There are popular tools identified for each of these phases that make our lives a little bit easier. On the planning phase, we have a popular tool called Jira, where we can set up boards and we can have iterations and we can have a track of basically who is doing what. And if there's any blocker, it can be used as a collaborative tool. For the create part, this is more of a playground for the developers. They can choose a choice of technology, which could be Java, Python, to create the solutions. And once they are done with the development of the code, they can verify and package their code by means of a tool called Maven, which is appropriate tool for packaging Java applications. Once, once the application is packaged, DevOps people take it from there and try to deploy the same application into AWS in form of a release and configure AWS infrastructure accordingly as required. Here we're taking an example of AWS. The next step of the Infinity is to configure resources according to application demands, and this can be done by a tool called Terraform, which is very popular in the market. Once we have done everything and application is up and running, we also need to move into the monitoring phase of the Infinity, where we use a tool called Prometheus. Prometheus is a real-time data scraping tool which can gather analytics of the applications deployed. And if everything seems healthy, we move to the next iteration and we go for the planning again. This looks like a pretty straightforward solution for application development and delivery, but don't get me wrong, this is not it. The actual DevOps Infinity might sometimes look like this, and sometimes like a periodic table, like this. Yeah, there is a lot of tools in the market that DevOps engineers play on, and the list is never ending. Finally, reaching towards the end of this video, let us look at the takeaways that we have right now. At the end of this video, you would be able to answer questions like how application delivery happens in a real world scenario, what is DevOps, what role does DevOps play in application delivery, and what are some common tools used in DevOps. I believe you've got answers to all four of these questions, and if that is the case, this video was a success. So that was it, my first video on this series. Thank you for bearing with me. Have a good time. See you again.